All right, 8.5 sum and difference formulas. So the sum and difference formulas are, let's see, what is that? What is this? Oh, that's weird. Okay, so sum and difference formulas going to be using here. Ready to go. Where are they? There we go. So these are our formulas. And let me just grab them and go back to this. Where is it? Here we go. Can't put them in here. Forgot, can't put them in here. All right, well, we can still do this. So want to know what cosine of 105 degrees is? So cosine of 105 degrees. First of all, we need to rewrite this as a sum of two common angles that we know, because we're asked for the exact value. So this is not a calculator problem. So I realize that that's 60 degrees plus 45 degrees. Those are two common angles. So now I can use this, that if I have cosine of two things being added, I'm going to do cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. So let's go ahead and do that. So this will be equal to cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. All right, now cosine of 60 degrees, I'm not going to do this for every problem, but for every one of these, but cosine of 60 degrees, we go to 60 degrees. Cosine is the x coordinate, which is 1/2. That's 1/2. Cosine of 45 degrees is going to be the x coordinate here is √2/2. So this is √2/2 minus sine of 60 degrees, which is the y coordinate here, which is √3/2. So √3/2. And then times sine of 45, which is the y coordinate here, which is √2/2. And so now we multiply straight across here. First, we get √2/4. Then minus, then we multiply across there, we get √6/4. So our answer is √2 minus √6 all over 4. Okay, I don't want to type these answers in. Let's just move on. Okay, same thing, but with tangent now of 165. So tangent of 165 degrees. So we need to look at this as a common angle. So let me see. What can we do to add together? So 90 and 75, it's not going to work. 180, take away 15. I'm not seeing it. 165. Where are we? 165. We're about in here. So how about here? This is 225. And then if we subtract from that 60 degrees, and I think that works. So yeah, so 225 and take away 60 degrees will be here. So this is going to be equal to tangent of 225 minus 60 degrees. And now we can use the formula, this one right here. So if we have tangent of alpha minus beta, we're going to go tangent alpha minus tangent beta. So for us, it'll be tangent of 225 minus tangent of 60, and then over 1 plus tangent of the 2 multiplied. So this will be tangent of 225 minus tangent of 60 over 1 plus tangent of 225 times tangent of 60. Okay, so at 225 degrees tangent, this is the y coordinate divided by the x, but this is going to be negative √2/2, and this is negative √2/2. And so when we take the y and divide by x, we get 1. So this is going to be 1 minus, okay, tangent of 60 degrees. So we go to 60, we go to 60 degrees, and we have 1/2 √3/2. So tangent means you take the y coordinate, divide it by the x coordinate, which is the same as multiplying by the reciprocal. 2's cancel, you get √3 here. So it's going to be minus √3 over 1 plus, and then you have tangent 225, which is 1 times √3. So this is going to be 1 minus √3 over 1 plus √3. That's it. All right, so sine of 25 pi over 12. Okay, so we got to figure out how can we look at 25 pi over 12 as one of our common angles. So one thing that we talked about in class is if you look at the 12 as being a common denominator between 3 and 4, so let's put a pi here and a pi here. Is there a way I can add up or subtract 2 fractions here? Let's try adding. So if we did this, if one was 3 down here and the other one was 4, maybe we can look at this 25 over 12 as being something over 12 pi plus something over 12 pi. And then how could we get 25? So we could do maybe like, they have to be numbers that can reduce out to be 3 and 4. So let me see, we could have like a 4 up here, but then that would make this a 21, and that's not something we know. We could have like an 8 up here, but then that would be the 17, and that's not something we know. So let's go with another multiple of 4. So 4, 8, 12. We could try 12 here, but then that's 13. That's not going to work. So how about, where were we? 12, 16, go 16 here, and then that would be 9. Those reduce, so 16, 4 goes into both of those. So 4 over 3 pi, and then plus over here, if we reduce, we get 3/4 pi, or 3 pi over 4. So 4 pi over 3 plus 3 pi over 4. Let's see where those are. 4 pi over 3 is count by pi over 3. 1, 2, 3, 4. There's 4 pi over 3. And then the other one is 3 pi over 4, which is going to be this way right here. Those are our 2 angles. So that should work. So we're going to look at this as being sine of 4 pi over 3 plus 3 pi over 4. And then we can use the sum formula, which is going to be, for sine, it's sine of alpha plus beta, sine of alpha cosine beta plus cosine alpha sine beta. So that's what I'm about to use. So this is going to be sine of alpha cosine of beta plus cosine of alpha sine of beta. Okay, so let's do these. All right, let's figure out 4 pi over 3, our coordinates here are -1/2, negative √3/2, and then here it is negative √2/2, and then √2/2. So now sine of 4 pi over 3 is the y coordinate here, that's negative √3/2, times cosine of 3 pi over 4, which is the x coordinate here, negative √2/2, plus cosine of 4 pi over 3, which is the x coordinate here, which is -1/2, times sine of 3 pi over 4, which is going to be the y coordinate here. And that should be, let's see, if we multiply those two together, we get √6/4, and then minus, because this is a negative here, and then we'll get √2/4. So this gives us √6 minus √2/4. Let me type this answer in. So it's a fraction. I've got square root of 6 minus square root of 2 over 4. Let me check that thing. Good job, good job. Okay, recording, yes. Okay, so on these, I think, well, I think I'll do one more. If there's another one after this, I think I'm going to go past it. So secant of negative 5 pi over 4. Well, this is actually a common angle. So we can just go, pi over 4, but we count negative. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Here's 5 pi over 4 right here. And secant is the reciprocal of cosine. The x-coordinate here is negative root 2 over 2. So secant of that should just be that flipped over, which is going to be 2 over negative root 2. So I didn't even need anything on this one. 2 over negative root 2. Oh, goodness gracious. What's going on? Secant reciprocal of cosine. 1, 2, 3, 4, 5. Do they want, they probably want me to rationalize that. Yeah, they want me to rationalize that. Okay, I'm moving on. They wanted me to multiply the top and bottom by square root of 2, which I didn't do. Okay, point. All right, here we go. So find the exact value. Cosine of 10 degrees, cosine of 50 degrees, minus sine of 10 degrees, sine of 50 degrees. So they want us to recognize that that's one of these formulas where we have cosine, cosine, and then minus sine, sine right here. And we know that that's cosine of alpha plus beta. So this should be just cosine of alpha, which is 10 degrees, plus beta, which is 50 degrees. So this is cosine of 60 degrees. And we know here, we've been here before, cosine is the x-coordinate here at 60 degrees. That's going to be 1/2. Okay. All right, so this is another one where we're supposed to recognize this. So I bring up the formulas again. We're looking for tangent of something plus tangent of something else, and then we have 1 minus those two things multiplied. So in the formula, here's the one right here. And so you can see this is just tangent of alpha plus beta. So we just say this is just tangent of alpha, which is 25 degrees, plus beta, which is 20 degrees. This is tangent of 45 degrees. And at 45 degrees, tangent is the y over the x, but they're the same numbers here, root 2 over 2, root 2 over 2, so we should just get 1 here. All right, so this one, same thing. We want to recognize a sine of something, cosine of something else, minus, and then cosine sine. So that one on our formula sheet is going to be this one, right? Sine, cosine, minus, cosine, sine. So this is sine of alpha minus beta. So this will be sine of alpha, which is pi over 3, minus beta, which is 13 pi over 12. So what we need to do here is get a common denominator between those. So I multiply 4 on top and bottom here. So this is sine of 4 pi minus 13 pi, all over the common denominator 12. And this is sine of, let's see, on top we get negative 9 over 12 pi. And this is sine of, reduce that fraction, negative 3 over 4 pi. So negative 3/4 pi. So on the unit circle, if we start going by pi over 4s, we count them 1, 2, here's 3 pi over 4. So we're here. We want sine, which is the y coordinate, that's negative root 2 over 2. So negative root 2 over 2. Okay, here we go. Now we're getting something here. So they give us some information. They give us that sine of alpha equals 4/5. That alpha is between 0 and pi/2. They give us that cosine of beta is 2√85/85. And it tells us that beta is between -pi/2 and 0. Okay, so they want to know what sine of alpha plus beta is, what cosine alpha plus beta is, and then sine alpha minus beta, tangent minus alpha minus beta. All right, so we need to figure out, first of all, since we wanted to find out what sine of alpha plus beta is, we're going to need to know both sine and cosine of alpha, and we also have to know sine and cosine of beta. Here we only know one thing about each of them. So here's where we have to draw a picture where we are. So we're between 0 and pi/2. So that means we are in the first quadrant. And we know that we're a point out here. We know that we have an x and a y coordinate. And since sine, by definition, sine of alpha will be the y coordinate time divided by the radius, we know that the y coordinate here must be 4 and the radius must be 5. And so we can use the Pythagorean by saying that this is going to be 4 and this is going to be 5. And we can say that the x coordinate squared plus the y coordinate squared must equal the radius squared. And if we solve for x, we're going to get plus or minus 3. But we're going to use the positive x because we are in the first quadrant. So that means that cosine of alpha will be the x coordinate 3 over the hypotenuse or the radius 5. So now we know what sine of alpha is. Now we know what cosine of alpha is. Now we go and do the same thing for beta. So for the angle, where are we? Well, beta is between -pi/2. So -pi/2 is down the fourth quadrant, and then 0. So we're down in the fourth quadrant down here. And we're given cosine of beta. Cosine of beta is your x over your r. And that means your x is 2√85 and your r is 85. And so if I draw a little triangle here, my x must be 2√85. My y coordinate is some y coordinate, and then my r is 85. So using the Pythagorean, I get 2√85 squared plus the y squared must equal the 85 squared. And keep in mind, because we're in the fourth quadrant, that the y is going to have to be negative. So let's go ahead and square this. When I square it, I get 4 times square the square root, you get 85, plus y squared equals 85 squared. Now I will subtract on both sides. 85 squared minus 4 times 85. And then now I take the square root. So y equals plus or minus the square root. Now I'm going to get on my calculator and see what that number is. So 85 squared minus 4 times 85. So I don't think that's a perfect square, is it? No, it's √6885. And I'm going to take the negative one. So y is equal to negative √6885. And so let's see here. They're going to want me to reduce that, I know. So let's see, or they're going to want me to simplify that. So 6885, let's 6885. So 9 goes in there. So this is the same as 9 times 765. I can pull a 3 out, so 65. Let me see if anything else goes in there. Oh, 9 goes in again, so 9 times 85, square root 3 negative. So I can pull another 3 out, so I get -9√85. There we go. That's what y is. So sine of beta will be the y coordinate, which we just said was -9√85 over 85, which is the r. So now I know what sine beta is, and I know what cosine beta is. So now I'm only going to do one of these at a time. Okay, sine of alpha plus beta will be equal to sine alpha cosine beta plus cosine alpha sine beta. Oops, beta. So this will be equal to, just start plugging them in. Sine of alpha is 4/5. Cosine of beta is 2 root 85 over 85. Then plus cosine of alpha, which is 3/5. And then sine of beta, which is negative 9 root 85 over 85. Okay, so we multiply here across the top, we get 8 root 85 over, let's see, 5 times 85 is 425. And this will turn out to be a minus because there's a negative sign there. So that'll be negative 27 root 85 over 425. And these are like radicals, so we can subtract. We have 8 of them, and we're taking away 27 of them. So that's going to give us negative 19 root 85 over 425. Yeah, let's see if it'll take that answer here. Negative 19 square root of 85 divided by 425. It took it. Okay, so I hope that all makes sense. I'm going to move on because the rest of these are just plugging into the formulas, and I don't want to go through all that. So that's it for that one. Oops. Okay, this is a similar problem. I think I'll just set it up, but I got to pause for a moment. Okay, so for this one, I'm going to set things up here. Let's look at this first piece of information. I know that tangent of alpha is negative 3 over 4, and I am in, let's see, pi over 2 to pi. So I know that I am in the pi over 2 to pi, so I'm in the second quadrant. And because of that, I know my x coordinate should be negative and my y should be positive. So tangent, by definition, is always your y over your x. And be real careful here because, again, your x coordinate should be negative and your y coordinate should be positive. So I'm going to look at that fraction as being 3 over negative 4. That means my y is 3, my x is negative 4. So this is negative 4, this is 3. And then to get r, we just do the Pythagorean. So negative 4 squared plus 3 squared equals r squared. So 16 plus 9 is r squared. So if you solve this, you'll get r is 20, r squared is 25, so r is 5. And r always has to be positive. That's why I'm not looking at the negative here. So from this, I know that, you know, x is equal to negative 4, y is equal to 3, and r is equal to 5. So if I want to know what sine of alpha is, it's the y over r, and cosine of alpha is going to be the x over r. So now I have what I need to use the formula. Well, half of it. Now I need to go get the information about beta. So here, I'm told cosine of beta is root 3 over 2. And beta is between 0 and pi over 2. So we're in the first quadrant. And this one is actually a common angle. This is cosine is the x coordinate. So I know I'm at 30 degrees, right? Because this is root 3 over 2 1/2. So I already know that sine of beta should just be the y coordinate there, which is 1/2. Now you could do it with a triangle, but I'm not going to because it's an easier angle because we know this. So you have everything you need. Now you can just start plugging into these formulas and you're off to the races. Okay, so here we have a different one. We're given that sine of theta is 5 over 6, and theta is in the second quadrant. So we are over here in the second quadrant. Sine is your y divided by your r. So I know that the y coordinate here is 5, and I know my radius is 6. So I need to find x, which will be negative because we are in the second quadrant. And so I know x squared plus 5 squared equals 6 squared, Pythagorean. X squared equals 36 minus 25. That means x squared equals 11. So x equals plus or minus root 11. And we're going to take the negative because of the second quadrant. So if I want to know here, what is cosine of theta? This will be the x coordinate negative root 11 over the r, which is 6. Okay, so let me see what's the other stuff they're doing here. That's cosine of this. Now, what is sine of theta plus pi over 6? Okay, so what are they doing here? Oh, I know what they're doing. Okay, so if I want to know what this is, the cosine of theta is, let me put the answer in, that way we know we got it right. So this is negative square root of 11 divided by 6. Okay, so now the next part, what they want you to do here is use your sum difference formulas. Sine of theta plus pi over 6. The formula for this is sine of theta cosine of pi over 6 plus cosine of theta sine of pi over 6. That's just your sum formula right here. I'm covering it up, but you can kind of see it right here. This one, number 4. So I'm using that. And we know sine of theta, we just have, sine of theta is here. So that's 5/6 times cosine of pi over 6. So at pi over 6 on the unit circle is here, cosine is the x coordinate. So that's root 3 over 2 plus cosine of theta, which is negative root 11 over 6. We did that earlier, times sine of pi over 6, which is the y coordinate here, which is 1/2. So this is 5 root 3 minus root 11, and we have a common denominator of 12. So that's this. And then these two work the same exact way using the sum and difference formulas for cosine and tangent, except, you know, you're not doing like theta and alpha or theta and beta. This is given, so you'll be able to find those values off of just your common angles. So I hope that works for you. All right, so this is an interesting problem. Didn't do anything like this in class. Use the figures to evaluate the function if f of x is sine of x. Okay, so first let's just figure out what this means. So they want to know what f of alpha plus beta is. So since they're telling us, okay, so since they're telling us that the function f of x is sine of x, if we want to know what f of alpha plus beta is, then that really means we want to know what sine of alpha plus beta is. Okay, so ultimately we want to know this. Now, we need to look at these pictures to figure out the information about, wow, that's not very big. Let's try this. Yeah, there we go. Okay, so here's the angle alpha, and it goes to this point here. It has the coordinates x. They don't tell us the x coordinate, but they tell us the y coordinate is -1. And they tell us that this is the equation of a circle. That's what x squared plus y squared equals 4 is. And so this equation of a circle, the 4 tells us that the radius of this is 2. So we know that this is 2. We know r is 2. We also know that the y coordinate is -1. And so if we do like a little right triangle, this is -1. So we need to find the x coordinate, which is also negative, because we're down here in the third quadrant. So we do x squared plus -1 squared equals 2 squared. So x squared plus 1 equals 4. So x squared equals 3. So x is plus or minus root 3, but we're going to take the -1. So now we know that the x coordinate is negative root 3. Okay, so once we know this, we know everything we need to know about alpha. We know that sine of alpha will be the y coordinate over the radius. We know that cosine of alpha will be the x coordinate over the radius. And so now we can figure this out using the sum formula, but we now need to know what's going on with beta. So we bring up the other picture. So for this one, I'll do it over here. We're over here in the second quadrant, right? We're given that the x coordinate here is -1/3. And the radius, because it's a circle with the radius, that right there, the 1 means that the radius is 1. This is 1. We know that the x coordinate is -1/3. So we need to figure out the y coordinate, which should be positive. So -1/3 squared plus the y squared equals the 1 squared. When I square -1/3, I get 1/9. plus y squared equals 1. Subtract 1/9 from both sides, and we get 8/9. And then we do the square root on that, and we get square root of 8 over square root of 9, which is 3. And then it'll be plus or minus. And because we're up here in the second quadrant, this will be the positive answer. And I'm going to turn this into 2√2 on top. So I just broke this up into 4 times 2 and brought the square root 4 out as a 2. So that should be our y coordinate. So we have everything. We have the x coordinate, we have the y coordinate, we have the radius is 1. So if I want to know what sine of beta is, that should be the y coordinate, which is this 2√2 over 3, but then over the radius, which is 1. So I'm just going to leave it. And then cosine of beta is the x coordinate, which is negative 1/3 over the radius, again over 1, but I don't need that because anything over 1 is itself. So I have everything I need. I have everything I need to know about sine and cosine of alpha and everything about beta. So I should be able to just use the sum formula here. All right, I'm not going to put it in. That gives you enough, I think, to do the problem. Same thing, this one's the same, except it's cosine instead. So you want to know cosine of alpha minus beta, and then you just use these again to, actually, those are the same circles. Looks like, yeah. Okay, I think this is probably going to be it for tonight. All right, I'm going to stop this.